Right. All right, so welcome. Today is Tuesday, the 25th of October, and as it says on the email I sent out just a couple minutes ago, we're going to go over chapters 15 and 16 today. Plus, we'll go over another one of the lab examples. I did one yesterday, and I will do another one today. All right, tomorrow will be a lab period. As it says, no taping will be done. Tomorrow, I will email you a copy of the chapter 14 through 16 pretest. Thursday, I'll go over the pretest beginning at 9:30. Friday will be a lab, and so will next Monday. Now, I got an email yesterday from one of the students, and you know who you are, um, who said basically, is it just me? That the class has kind of made sense so far, but since we've gotten to chapter 12, I've kind of hit a roadblock. All right. And I will tell you that I think I said this earlier in the semester, and that is that in my humble opinion, this is the hardest part of the class. I think the stuff that we'll do starting later next week when we go into files and link, I don't think you'll find that stuff that difficult. The database stuff, it's a little bit different, let's put it that way, but I don't think it's as difficult as this is. And what I'm going to try to do, I've gone and written the pretest, but I'm going back and I'm rewriting it because I'm trying to give you an example that's going to kind of tie together everything that's in this section. And what do I mean by that? Well, the ability to create classes, the ability to run validation, the ability to do what we'll talk about today, and that is a little bit of interfaces and the ability to basically package everything up into a class library. Now, when we get done today, we're going to take a quick look at both the whatever, we've already looked a little bit at the labs, and we're going to look at those again. And then we're also going to look at the homework. All right. I'm more concerned. I'd rather give you a few problems and have you understand them than inundate you and give you tons of problems and have you not understand them. All right. So like I said, that's my way of doing things. Whether that's going to be right or wrong, I guess we'll see. Now, Monday, as it says, will be a lab period. As of right now, then Tuesday, 1 week from today, on November 1st, I think that will be your next hands-on test. Hands-on test 7. All right. There is a chance that may be the last hands-on test. I think there'll be one more. All right. But that'll be it then. What I'm looking at right now is starting next week after Wednesday, we're going to go over chapters 17 and 18. We'll probably have another test after that. But then in lieu of a test for the end of the semester for the database stuff, I think we're just going to do a project as a class, and I'll get you to a certain point and then you'll kind of take over on it. All right. So with all that said, then let's start. So I'm going to close this and I'm going to go into here. So again, we're finishing up section 3 of the text today. As you can see in section 3, it says how to work with interfaces and generics. I find generics to be probably about generics and indexers, which were in the chapter that we skipped in chapter 13. It's some of the most difficult stuff to understand. So the only part I'm going to go over in here will be the stuff that talks about interfaces. And if you think about it, Grant, please remind me because I don't want to forget that by the end of the period today, I want to make sure, like I said, I go over with you what will be due on November 1st. All right. So as it says, the chapter starts by talking about interfaces. All right. And it says they're similar to abstract classes, but they have some advantages. I'll tell you what the biggest advantage is. Okay. When you are setting up, and I'm going to show you something real crude here for just a second, kind of what I showed you yesterday. And that is, yesterday we talked about, maybe having a class called animal, and then underneath that having another class called human, and then maybe one called dog, and maybe one called cat, And I think yesterday I used fish, but we'll use bird. All right. Something like that. Well, one thing about this is when you work with C sharp, you can only have single inheritance. In other words, all right, to my knowledge, dogs and cats don't breed, but with each other, but let's just say they did. And we came up with a DAT, which was a dog and a cat. I mean, this is kind of a stupid thing to say, but just bear with me for a second, because what I want you to understand is this. It is not possible in a language like C sharp for you to inherit from both dog and from cat. You can only have what's referred to as single inheritance in here. Now, there's another language that's similar to C sharp that we don't teach here that's called C++. And with C++, you can have multiple inheritance. But what I'm trying to get across here is that when you start doing this stuff, that any class that you have can inherit from any other class, but only from one class. So all of these would inherit from animal. So, you'd have public class, human, animal, dog, animal, etc. You wouldn't put anything here. So by default, animal inherits from object, because that's the thing at the top of the hierarchy. All right. Well, so why am I even telling you this? Because even though you can only inherit from one class, you can have as many interfaces that you inherit from as you want to or need to have. All right. So C sharp supports single inheritance, which means that you can inherit from 0 or 1 classes, but it supports multiple interface inheritance, which means you can inherit from 0, 1, or more interfaces. Hopefully I made that easier to understand and not harder. Guess again, we'll see. So we're going to spend the first 10 or 15 pages of the chapter talking about interfaces. All right. And I'm going to quickly look at the end of the class today and see what the assignment is for the homework for interfaces, because to my knowledge, there's nothing for the labs and interfaces, and I very well might not give you the one in here either in the homework. All right, and we're going to skip the thing on generics. Feel free to read that. If you have questions, I'll do my best to try to answer them. All right, so it says in here, in some ways, an interface is similar to an abstract class. So there'll be a comparison on the next page. All right, but again, you can have multiple interface inheritance. All right, and they even say that in here. It says an important difference between abstract classes and interfaces. C sharp can only inherit from one class, but it can implement more than one interface. So you do inherit classes, you implement interfaces. Now, who cares? Well, the reason that that's kind of important is you do it in the same way. So even if you implement an interface, it's colon followed by whatever it is you're going to implement. So what you can actually put in there is, for instance, I could have had something like public class dog colon, and then we could have said animal, and then I think it's a comma, and then we could have listed one or more interfaces. And if that confuses you, you're going to see some examples of it in just a moment. All right. A lot of times what people will do is they'll try to write sometimes very generic interfaces, sometimes very specific interfaces. And what I mean by that is sometimes people like to kind of package up everything they're doing into an interface and say, now you can implement this interface and you can implement this interface, etc. So they do it in a very generic manner, thinking that virtually anybody who wants to create a class of this will also want to implement this interface. Other times it's just the opposite, that people will set up interfaces that will be for things that are very specific. All right. And again, you're going to see some examples of this. So when you look at it, it doesn't say class. When you look at the example here at the top of page 497, it says interface. All right, but you'll notice that when you do this, it's still colon and then the name of the interface. Now, it's pretty much a standard practice in C#, in Java, and in most programming languages that support interfaces that you always start an interface with a capital I. So the name of your interface should just begin with a capital I. You should never have classes that begin with a capital I if you can help it, because I pretty much designates that this is an interface. All right. So what it's saying there is we've got this interface right here that's going to allow this display text method, as you can see. All right. And then you've got a class that can basically come in there and use it. So it's like, what is the big example or the big advantage of doing this? Well, let's take a look. Again, as it says, both of them can provide signatures. Remember, the signature for properties and methods is basically typically what appears in the parentheses. Both can implement some or all properties and methods. An abstract class can use instance variables and constants and static variables. All right, an abstract class can use instance variables and constants and static variables. An interface can only use static variables and constants. So it's things that are shared. The idea behind an interface is, again, the stuff that's in there is going to be shared. And again, a class can inherit from only one class, but it can implement 0, 1, or more interfaces. Now, again, like I said, that's why this stuff, until you really see it in action, it doesn't make a whole heck of a lot of sense. And sometimes after you see it in action, it still doesn't make a whole heck of a lot of sense. And I get that. I really do. All right, there are whole books. I remember one day I was at a mall with my wife, and at the mall they happened to have a Borders bookstore in there. And she was shopping. I'm not a shopper. So I'm sitting there in Borders, and I found a book, and it wasn't the best book I've ever read, but it was called The Poop on Oop. And it was, I don't know how long it was. I can look it up now, but I'm not going to. And you can buy entire books just on object orientation. And a lot of people, I've heard this comment made that, I do understand, at least have a peripheral understanding of object-oriented programming, but I still don't understand why you have to use it. And in most programming languages, you don't have to use it. But using it provides a lot easier way for you to be able to share things and reuse things. That's the main reason that it's used. All right. So it says .NET defines hundreds of interfaces. It says, fortunately, most of them are used by other .NET classes, so you don't need to learn them all. So they're going to give you a few of them on the next page here. And again, you'll notice I, clonable, I, comparable, I, convertible, I, disposable. All right. It says, of these four, the one you're most likely to implement is I, clonable, which lets you create objects that can produce copies of themselves so they can make clones. So here are some of them. I will tell you the one that I use the most often is I, comparable, the second one that's shown there. Why? Because it allows you to compare two things, and usually when you've got some kind of an interface or a method or something with comparable, it allows you to compare two things. If the first thing you're comparing is considered to be less than the second thing you're comparing, it returns typically -1. If the two things you're comparing are equal, it returns 0. And if the two things that you're comparing, if the first one is greater than the second one, it returns +1. Now, this is with objects, so it's not exactly the same thing, but it's pretty much does work the same way. All right. Notice commonly used .NET interfaces for collections. Like I said, we've done a little bit of work with collections. All right. Mr. Gudmundsson and I go back and forth over whether or not this is an excellent book to be teaching you C# or sometimes it falls flat, and maybe we should have a different book. At the end of the semester, you are all going to do a course evaluation where it's three-pronged. You evaluate the course. In other words, did it do what it said it was going to do? You evaluate the textbook. All right. In other words, is it the right text for the class? And you evaluate the instructor. In my case, of course, it's me. And did I do a good job of presenting the information to you? And all I ever ask is that people be honest. If you got a problem with me and my pedagogy and the way I teach or whatever, put that down. That's the only way I get better. It's all, everything that you do is totally anonymous. I never see it. I just get a summary of everything. Okay. So again, .NET defines many interfaces that you can implement in your classes. All right. And again, the table, as it says there, lists only the most important members of each interface. For a complete description, see the online documentation. And one thing to realize is every time you see something like this, if where the author said, well, these are the four you're going to use most often, that's in the author's opinion. All right. In fact, they even said the iClonable one's the one you're going to use the most often, where I said that's not the one I use the most often. So it'll vary. All right. So not only can you use built-in interfaces, you can create your own interface. So let's see how they do that here. All right. So you'll notice again, it's not public class, it's public interface. And they can contain methods, they can contain properties, etc. All right, so they've got the example, that's the same one that they gave you before. All right, and then there's another one here too. Again, I've gone through this example before where people have said, this is confusing. Yes, it is. All right, so the declaration for an interface is similar to the declaration for a class. That should make sense. All right, the only difference is, again, you use the word interface as opposed to coming in and using the word class. All right, it says the non-default methods and properties that are declared within an interface can't include implementation. That's the big thing. You don't put any actual code in here. This is just the name. And what this says in English, what this says is an interface, you've got to kind of look at it this way. What you're going to start hearing next semester, if you're taking, well, depending on the class you're taking. If this is your first class, you'll hear it in 2 semesters. All right. But you're going to start hearing the term application program interface, or API. An interface right here, this is a contract, this line of code. This line of code right here, that one that you see right there, it says, hey, if you decide you are going to implement this interface in your program, then you must include in your code a getDisplayText method. It must return a string and it must take in a string. So again, an interface, for lack of better words, is a contract. And what it's saying is, okay, I'm going to provide these services for you, but for you to use those services that I am providing, you've got to agree to use them in the way that I'm setting them up for you. All right. Again, like I said, that's why many books will refer to this as being a contract, for lack of better words. And like I said, you may agree with that, you may not agree with that, and really in the end, it doesn't matter. All right. But much of the work that you end up doing as a programmer, much of that work, you will end up using interfaces in one form or another. All right. Implementing an interface basically just says you're going to use it. All right. So again, what it's saying is, hey, we've declared this interface. Well, then you've got to bring it into the program by saying the name of your class, colon, the name of your interface. So again, bottom line, I know you've already heard it before, but with these classes, they are either going to inherit from a class or from object, and they're either going to have 0, 1, or more interfaces. All right, and you inherit a class and you implement an interface. All right, that's the best way I can put it to you. All right, I don't want to go through this example because again, it goes through the clonable, and I just thought, I went through it yesterday more than once, and I thought this is going to be too confusing for people to understand. Okay, so I'm going to jump right into the next chapter, which is chapter 16. Chapter 16, in many ways at least, it kind of attempts to bring together what we've done in chapters 12, 13, 14, and 15. All right. And what it talks about in there, as you can see, and it's not a long chapter, it's how to organize your classes, it's how to test your classes, it's how to document your classes. And to me, probably the most important part in here is this last part that you see on this, well, this part, and that is class libraries. Class libraries involve you packaging together code that naturally belongs together. All right. And the advantage of putting something into a class library is that you can use it in multiple projects. All right. It's a one-stop shop. In other words, you put everything you want for that. A library can hold multiple classes and typically does. All right. But it allows you to bring in everything at one time. Okay. So we'll talk a little bit about how to organize classes, how to document them, how to create and use class libraries, and how to implement unit testing. All right, so let's jump into this. All right, so how to organize your classes. First says how to code multiple classes in a single file. Now, I'm giving you my own take on this. So you may totally disagree with what I'm about to say. C# is somewhat unique in that they let you put multiple public classes in the same file. All right. Now, if you use a language like, for example, Java, you can have multiple classes in the same file, but only one of those classes can be public. The rest must be what are called private. And you might be thinking, fine, who cares? The bottom line is this. I would never recommend putting a class inside of a class in this language. I would recommend putting them in multiple classes. Now, this is the author's take on this. When two classes are closely related, it sometimes makes sense to code them in the same file, especially if each is relatively small. That way, the project consists of fewer files, and it might actually run faster. I think what typically happens, though, when you do this is over time, classes tend to grow. People decide they want to put more things in them, give more options, etc. So what may start out as two very small files, maybe each 10 to 20 lines, can quickly escalate where one or both of them have maybe several hundred lines. So I would recommend not doing that. All right. So it says one way to code two classes is to code them one right after the other. That's this example here. So in the same file, you'd have public class 1, all right, and public class 2. All right. Now, yesterday, after you left, Grant, I went over that photo example, and it had two classes in it. All right. It had one class that was called letter and one class that was called certified letter. And we put them into two different files. So we had a public class letter and a public class certified letter. What they're saying is we could have put them both in the same file. Again, I personally don't see the benefit of doing that. I understand what the author is saying, but I think especially when you're learning this stuff, you should try to be doing things that are intuitive, and you should try to be doing things that basically try to make sure that stuff is clear to people and they provide clarity. All right. Okay. So they said another way to code two classes is to nest one class or put one inside of another. It says this is useful when only one class is used, when one class is used only within the context of another class. But then you get stuff like this. When you want to refer to something, you have to use the name of the outer class dot the name of the inner class. And again, if you go, I don't even get that, I understand. All right. That's why I said I would recommend what they talk about next. All right. Now, or what we've been doing. Now it talks about how to split a single class across multiple files. So this is kind of the opposite. This is saying taking one class and putting it into multiple files. And again, why might you want to do that? Because the single file might get so big that you might decide that you want to put it into multiple files. Or this one class has a lot of different parts to it, so to speak, components, whatever you want to call them. And you might have different programmers or different programming teams building different parts of the same class. So to do that, as they mentioned, you code the partial keyword before the class. And as it says, that indicates that the members of the class may be split across multiple source files. Then, as it says, when you build a solution, the compiler puts them together for you. All right. So it says if the class you're working on is very long or you want to have different programmers work on different paths, this may make sense. We don't do anything in here really that is so huge that this becomes an issue. However, if you were a professional C# programmer and you were working on a very, very, very large project, I want to give you an example of what I'm talking about. All right, several years ago, I took a class that was a week-long class, and it was in downtown Milwaukee, Wisconsin. I walked in there, and there were about 20 people in there, and the teacher came in the first day, and he introduced himself, and he was a programmer for Johnson Controls. Now, if you don't know what that is, basically, they're pretty much the number one maker of thermostats, at least in this country, if not in the world. All right. The reason I'm taking a second to tell you this is he talked about the fact that everything they did, they were a Java shop. So they used the Java programming language, not JavaScript, Java. All right. And he said that everything they did was totally non-object oriented. So he was on a team that was given a task, and they were given basically 3 years to convert everything over that they were doing from non-object oriented to object oriented. So a natural question, somebody kind of asked him this, was, okay, but why are you doing that? That seems like a lot of work, and if it's working, etc. And he said that every single time they introduced a new product, they did a lot of reinventing the wheel, that there wasn't a lot of code typically that was similar to stuff they'd already done, but yet it was different. And their hope was that by making it an object-oriented solution, they wouldn't have to do that. So somebody asked then, okay, well, if it's a 3-year-long project, why is it taking that long? And he said, believe it or not, he said, we're in the middle of the first year, and all we're doing is we're writing an inheritance hierarchy that was almost like kind of like what I showed you here. And the question got asked then, okay, well, how many levels deep in it is it? And he said hundreds. He said, we are that big of a company, and the stuff we do is that meticulous, etc., that this is hundreds of levels deep. And he said, we've got different teams of programmers working on a lot of different stuff. So what I'm telling you is, again, these partial classes in the right situation make a lot of sense. All right. All right. So they show again, when you do that, you'll have to have public, you'll have to have the word partial in there. And you'll notice They're both files, public partial class customer, public partial class customer. All right, so you're going to have two different files that look like they're the same name because they are, because it's one class broken into two or more pieces. All right, you can do the same thing with forms. In fact, I believe every form that we've done so far says public partial forms. We just have not been breaking it up, so to speak. So again, it can be used to split code for a class across several files. All right, you enter the partial keyword as it says, all right, before the class keyword. All right, all partial classes must belong to the same namespace. This is just all stuff that if you're going to use this, that you've got to be aware of. All right, so the next thing that's in here is namespaces. And you've been using namespaces the entire year in here. So for instance, if I go back, this is the program we're going to work on today, and you'll notice namespace. By default, the namespace is going to have the name of the project. All right, but now we want to talk about what namespaces are. So the authors here define it as a container used to group related classes. Okay, so who cares? Well, it is a big thing because what is going to happen in the example that we're going to go through today is we're going to have a class called photos. It's not in here yet. We're going to make it in a few minutes. And then we're going to have two subclasses of photos, matted photos, all right, and framed photos. But all of the ones that we create will be in this namespace, this collection, all right? I brought in the validator class that we used before, all right? And when I brought it in, by default, because I copied it from the book, this did not say namespace LB2 photos. All right. It had the namespace that was in chapter 12 when this thing was first discussed. So what I did was I just went in and I grabbed all of the code that was inside of here, just all that code that had what? All the stuff we've been working on, this line end, is present, is decimal, which we're not going to use, is int 32, which we are going to use, and is within range, which we are going to use. So I brought all that code in and literally just plopped it right inside of public. I made a new empty class. It said public class validator. So I grabbed all of this code here because when I originally created it, that's what the class looked like. In fact, the curly braces were on the same line here. All right, so I grabbed all that code and put it in. The takeaway here is, in order to be able to use that in this project, all right, I wanted it in the same namespace. All right. So it says every C# class you create must belong to a namespace. Okay. Now, one thing we have not done, and we're going to talk about it in a few minutes, is bringing in other namespaces. But believe it or not, you've already done a little bit of that, even if you don't realize it. What do I mean? All these statements that are up here, using system, if you remember that we have using the windows.form. In fact, if I come over to here and we bring this up, there we go. Using system windows.form, using system.collection. What are we doing here? We're basically bringing in the equivalent of other namespaces. All right. And we're just making it available to our programmer in our program. You can nest namespaces. You can put a namespace within a namespace. All right. It says, for example, systems.collection is actually a namespace called collections. Do you have to worry about this stuff? Not really. All right. But the point is that for everything that you do in a program, there is a lot of stuff that's happening behind the scenes. And the author even says here, For simple C# projects, you typically don't need to worry about namespaces because Visual Studio will handle them for you. But again, if on the chance that you become a professional C# programmer, all right, then the stuff that you're going to be doing is, of course, going to be much more complex than the stuff that we're doing. All right. So we've talked about namespaces before. Okay. Again, you can have a namespace within a namespace. And if you want to bring in a different namespace, notice it's using followed by the path, so to speak, for that namespace. So I'm not going to read this to you, but because it's pretty much what I just told you. All right. The next thing that's in here, probably in this chapter, is probably the least important thing. All right. But it allows you to bring in another kind of documentation to a program, and that is XML documentation. And I'm going to give you, I'll try to keep it real short, like a minute or two. But back in the late 1980s, early 1990s, people were pretty sure that HTML, the hypertext markup language, which is used for basically every web page that you can write, but it was dead. It had outlived its usefulness. So some people got together and decided, you know what, we need a new markup language. So they came up with something called the extensible markup language, which is just called XML. The reason that that's important is with the extensible markup language, you create all of your own tags. So HTML, which you'll talk about next semester in the AWD1000 class, has about 100 or so predefined tags that have a certain meaning and can only be used in a certain way. With XML, you can make your own tags and have them do whatever it is you want them to do. Well, again, people thought that this was going to be great. This was going to replace HTML, etc. But what happened is it soon proliferated out of control, and there were a couple hundred at least different dialects of XML. Everything from chemical XML to math XML. They even made one, for example, for chess, the game chess XML. So there were all sorts of them. The reason I'm telling you this is XML didn't really take off ever the way people thought it would. It's still used, all right? It is still used, but I don't think it ever became the godsend that people thought it would be. Well, when you are writing documentation, all right, when you are writing documentation, you can write documentation and put XML documentation in your program. You'll notice if you look on the screen that XML comments start with 3 slashes. 2 of them, just 2 slashes in a row, basically mean that it's a regular comment and it appears in green. 3 slashes, typically those will appear in gray. And the reason that that is important is it will basically lay out a framework, whereas you can see you can summarize different things in your program. It's a form of internal documentation. It used to be many years ago, like when I was your age, all right, that the documentation that came with software came in a manual. And I mean, usually in a really thick manual that could be hundreds, if not thousands of pages. Now, today, it's not like that anymore. The documentation is internal. So one way as a programmer that you can strive to make your documentation, your internal program documentation even clearer for people who are looking at your code is to write XML comments. And these are the biggest things that you use. Summaries, which as it says, you give general descriptions, values, returns, and params. Params are for parameters. All right. So I'm just going to leave it right there. There's nothing wrong with it at all. As it says, you can view it. So Visual Studio will use that documentation when it displays screen tips. So in other words, when you bring it up, you can tell it to show different kinds of documentation. All right. So you'll notice that if you highlight something here, you can basically have it come up, and this would be the XML summary that you put in here. All right. And again, the idea is you want to make sure that if you create some code with the idea that you're writing something, but somebody else is probably going to end up maintaining it and doing the work with it later, that you want to give them as much information as you can. You want to make it as easy for them as you can. And the main reason that you're doing that, to be honest with you, typically is selfishness. And what I mean is, I've written code as a programmer, and I've had people come back to me days, months, years later and say, hey, can you help me with this? All right. And I've always tried to, many people say I over document, but I'd rather do that because, I've also had situations where I put so many comments in that when I ask the guy, do you understand this? They'll be like, yeah, you've got everything I could think of asking is here in the documentation. All right, and XML documentation is just another type you can use. All right, so class libraries. It says, so far the classes that you've seen have been created as part of a forms project. So in other words, when we come in here and we do something like this, all right, so we come in here and I've got a validator class, and later I'm going to right mouse click on here, and I'm going to choose classes, and I'm going to make photo, and then right mouse click and choose classes and make form. I don't remember what they're called, formatted photo, and whatever it is. And we're going to make those. But the point is, when you do it that way, all these classes basically are kind of stuck, for lack of better words, to the project. They're tethered to the project in which they're created. So there's not a lot of usability. But as it says here, if you want to be able to use classes in 2 or more projects, you'll want to put them into class libraries. There's a real simple definition. It's a collection of related classes. When you use a class library, you can use any of the classes without copying them into the project. All right, just basically by creating a reference to the library. All right. All right. So it says the next figure is going to show you the difference between basically what we have been doing and what you could do. All right. And that's what we're going to talk about, because pretty much this is the end of the chapter. There's a little bit more, but this is most of what's left in the chapter. It says, as you can see, the classes that are created in a Windows Form project must be included in every project that uses them. But if they're in a library, they exist separately. So they're available to any class that has access to them. I guess one way you could kind of look at this is, when you think about it, it's sort of the difference between having a library where you can go in there and you can check out books, and having a virtual library where somebody can go and check out a book virtually. In other words, they can get an electronic copy of it. So you can have multiple people viewing it at the same time. Whereas if it's in a library and there's only one copy of it and I want it, you've got it checked out. I've got to wait till you bring it back. All right. So as it says there, one of the benefits of doing this is that the size of each project that uses this library is reduced. So that's because each project only includes a reference to the library. All right. Or also because they've already been compiled, they don't have to be recompiled every time. So that's going to make your program run faster. Another benefit, as it says there, is maintenance. Because if there's a major change that has to be made to a class in the library, you're only changing it in one place. And since everybody is basically referencing that one place, all right, you don't have to change the applications themselves. As it says there, probably the biggest benefit, though, is the fact that it allows you to create reusable class libraries with reusable code. All right. So when we look at this, all right, they mentioned that, that if you basically had these in different libraries, you'd have to, without a library, I should say, you'd have to bring them into each one. That's what we've been doing so far. All right. But if they're in a class library, and you're going to see this, we're going to go through an example of this in a couple days. You won't have to do this for the test. You won't have to do this for any assignment. But the reason I want to go through it with you is for completeness, so that you see indeed how this is used. All right. So you can read this stuff. Okay. The only other thing I'd want to add about what's in here is this last bullet says to create a class library, you develop a class library project. What does that mean? That means if you look here, if I go into here and I right mouse click on my solution and I choose add and I choose new project, you've seen this kind of thing before. There's nothing new right here. But if I come up here and I type in class library, you'll notice there it is. Now, a class library, when you look at this, it's all code. There's no GUI to it. It is all code because it's a library of classes. And hopefully you've noticed so far with what we've been doing that everything that we've been doing when in regards to classes has been totally non-GUI. We still have our form files, etc., but the classes themselves are just code. A class library is just code. All right. It says, then when you build the project, Visual Studio creates a DLL file. A DLL is a dynamic link library file. For lack of better words, it's kind of like an executable. All right. That once you put it into your program, that means that you can use the stuff that's in the library. And that's not the greatest of explanations, but hopefully it makes at least a little sense. All right, and it says to use this, you use the template that's available. It's what I just showed you. All right, it says after you enter a name and a location, all right, Visual Studio creates a class library project for you that has, it's kind of a garbage class it puts in there. That's called class 1. You typically just get rid of that because you don't need it. You're going to make your own stuff. But if you look here, it says in the figure that we're going to look at in just a moment, says it shows a class library project named validation library that includes that validator class. Now, it may only have one class in it, but that's not to say that over time you couldn't put more classes in there. And it says, notice the name of the namespace for this class. When you place classes in a class library, you should create a namespace that indicates the purpose of that namespace. All right. Okay. It says when you're done designing it, again, you build it to create the assembly, and that's what's going to create the DLL file. All right. So they go through the steps in here, and this again can be as simple or as complex as you want it to be or need it to be. These external classes, hopefully this starts to show you some of the importance of using things like XML comments. I mean, anytime I use XML comments, and I don't use them that often, I'm not going to lie to you, but I use them a lot more in class files like this than I do in regular form files like we've been using. All right. And again, the idea behind this is you could have literally hundreds, thousands, or more people using the stuff that's in here. And there will at least come a time when somebody wants to use something and they don't, and it's like, why are we doing it like this? That's why you put the comments in there. All right. So next they show you how to add a reference. And again, we're going to be doing all this stuff. But I do want to mention, yes, we are going to be doing this stuff. No, you won't have to do it on any lab or homework or test. But I want to show it to you so you at least see how it's done. All right, as it says, to add a reference to a class library in a project, you use what's called the reference manager dialog box. All right. It says if you have created a class library as a project in the same solution, you can add the reference by selecting it in the project page of the reference manager dialog box. That's the way we're going to do it. All right, so you'll see that in a couple days. Finally, as it says there, once you've added a reference to a class library to your project, you can use the classes in there the same way you'd use any other class. All right. And again, they give you an example. It's not that easy to understand, but once you see it in action a time or so, hopefully at least, it'll make some sense. All right. The last thing that they talk about in here is unit testing, and I am going to spend a couple minutes on it. All right, then we'll take the break, or our first break. But before I do, let me just mention to you, I've given you, I don't know, scenarios like this before, but if you're working at a company of any size and you're working on a big project, and let's literally say it's 100,000 lines of code. That's actually not that big. All right. One of the projects I worked on when I was programming had 5 million lines of code. All right. But what's going to happen typically is you're going to take the different parts of the project and you're going to segregate them into units. All right. So when they talk about unit testing, there's two things that are important with unit testing. First of all, you've got to make sure that you didn't break anything that currently exists. So if I've got software and I'm adding a new feature to the software, I want to make sure that when I'm in the testing phase, that my new software doesn't break the existing software. Okay. And even more importantly than that, before I start doing that, I want to make sure that my software does what it's supposed to be doing. All right. So as it says in here, unit testing provides a way of testing individual methods to verify they work as expected. Now, I'm going to give you something very, very, very short here that you probably could care less about. All right, when I graduated from high school, I immediately went to college to the University of Wisconsin-Milwaukee, and I got a degree in journalism. I was a reporter for a while, all right, and I've been told that one reason that I was successful as a programmer is that I could actually write, where most programmers are not real good writers. Well, the reason that I'm telling you that is when I went to work at my first programming job, which was for AT&T Bell Laboratories, all right, one of the first things I had to do on one of my first projects was I had to go and bring a new feature into telephony so that the telephone was able to do something it couldn't do previously. These are back in the days of rotary telephones, etc. All right, but what I'm getting to is that I had to put in this new thing, and it was probably it was a few thousand lines of code. All right, and that may not sound like it's that big a thing, but I had to go and write unit tests for everything I was doing, and I had to put them into a designed unit test document. That document, I'm not exaggerating, was 500 pages long. It was the biggest thing I had ever written. And basically, I had to write a little bit of an introduction to it and a summary to it, but every page was a test that I had to run, what I expected to have happen when it ran, what I planned to do if I ran it and it didn't work, and then what happened when I did run it. And it was test after test after test after test after test. All right. So that is unit testing. All right. And then after I did that, and people signed off on it and they said that it was okay, that was me unit testing. Then we had another group that took over not just my part of the project, but other people's. They were called system testers. Their goal, believe it or not, was to break our code because they wanted to break the code before we actually gave it to our customers. All right. So as it says, you code one or more methods called unit tests for each method that you're testing with all of the possible inputs and outputs, all the logical paths. So you're trying to make your way through your code to see exactly what is supposed to happen and exactly what does happen. All right. They mentioned some of the advantages here of using unit tests. It says one advantage is it helps you identify problems earlier in the development cycle. The earlier you find a problem, the cheaper it is to fix it. If you let a product go out to the field where people are using it, and now you discover an error, those people might have to take their product and their website or whatever it is offline. They're losing money. All right. It also makes you look bad. All right. Another advantage, as it says there, is you can run these anytime you want to make a change to the code. So before you actually implement any changes, you can run unit tests to make sure that they don't break anything. And again, they work as intended. All right. So it says before you learn to create unit tests, you should know that by default, Visual Studio provides for 3 unit test frameworks for .NET. You can see them right there. We're not going to do anything with any of them. But as it says in here in this chapter, they use MS Test. MS is short for Microsoft. All right, the testing that was developed by Microsoft. So most of this stuff is what I've already told you. You want to make sure that your stuff works. You want to make sure that your stuff works and it doesn't break anything that's in there. And you've got to make sure that if either of those things don't happen, in other words, either it doesn't do what it's supposed to do, or it breaks something that was in there, as it says, you debug and you fix it. All right. And that's pretty much it. So they go through how to create a unit test project. I'm not going to run through this with you. All right. But again, this is the kind of thing, and I don't even know any other way to say it than this. Being a programmer is not glamorous. And one of the things that you spend a lot of time doing as a programmer, 2 things that you do. One is attending a lot of meetings, and the other one is testing your code. All right. In fact, those are probably the 2 biggest things that you do as a programmer. All right. So they show you how to run these tests and exactly, again, what should happen. All right. So that's it. Now, what I want to do, I'm not going to do it right now. We're going to take a break literally in a matter of seconds here. But I want to come in here and where is it? Uh, well, I'll look for it during the break. I'm going to go through right after the break before we even go through the problem, which we are going to go through. But before we do that, I'm going to go through the written tests, the labs, and the homeworks that are going to be due for chapters 13 through 16, I guess you'd say. So let's take a break. It is 9:04. So I've got plenty of time to do this. Let's just take till 9:20. All right, it's almost 9:05. So we'll take till 9:20. We'll pick it up in 15 minutes, and I'll show you exactly what I expect you to be doing. All right, so I'll see you back here in 15 minutes. All right, let me put my share back here. So let's talk here. This is the homework. Now, in just a couple minutes, we're going to be going through this photo example. And on here, there were, I don't know how many problems. We did the letters one yesterday. So that one is literally in yesterday's lecture. Today, we're going to look at the one with photos. All right. I already said we can skip numbers 3 and 4, this booster pack Pokemon thing, and this polymorph. I don't know what that is, if it's Pokemon or something else. I don't know. And I want you to do the bank login enhanced. You've already got a good start because we've already done the bank login. And I want you to try, at least attempt to do the network scan attack. All right. Now, in just a couple minutes, I'm going to be going over this number 2, this photos. All right. And you're welcome to do it, but even if you don't, it's okay. There's a lot of code in here, and there's a lot of stuff to be explained. So we're going to spend most of the rest of the period then going over this, but I will not make this as part of what's due. So you will have to do on the labs that will be due a week from Saturday on November 6th, you will have to do number 1, LB1 letters. You will have to do number 5, LB5 bank login enhanced, and you will have to do LB6 network scan attack. All right. You can do the LB2 one, which I'm going to do with you in just a couple minutes, but you don't have to. All right. That's the first part. Secondly, you've already or should have already turned in, I think, the test, unless that, I think that was already due, or if it's not due, that's due this week. But for chapter 12, but for the written tests, chapter 13, no, you don't have to do that. We didn't go over chapter 13, so how could I ask you to do the written test on it? All right, so forget about that one. Chapter 14, yes, I do want you to do this one on how to work with inheritance. I don't know how many questions there are, but I want you to go, yes, you do have to do the chapter 14 written test. Chapter 15, which we just started to go over today. Now, part of these questions are on interfaces and part of these are on other stuff. You don't have to do this one. So you do not have to do the written test for chapter 15. Chapter 16, which we just went over. Yes, I'd like you to do the written test for this. Even though we're not going to have any homework or labs or written or hands-on tests on this, I still want you to at least understand the concepts that are in here. So one more time, for your labs, I want you to do number 1, number 5, and number 6. Number 1 is the thing with letters. Number 5 is the enhanced bank login, and number 6 is that network scan attack. So that's for the labs. For the homework, for the written tests, chapter 14 and chapter 16. You have to do both of those. You do not have to do 13 or 15. All right. And then finally, for the extra exercises that are in here. Now, I think it was James, one of the James in the class that got a hold of me and said, hey, for this chapter 12 thing that you were supposed to do for the other day, it said, in this exercise, you'll add a class to the inventory management application. But I think the one that you had was actually the customer management. So I went and sent out the beginning for the inventory management. I'll check because I think that for chapter 14, this use inheritance, I think again, they are expecting you to have something that you may or may not have. I don't know, but I will look at this after class. And if necessary, I will send you out this. So yes, you have to do 14.1. No, you don't have to do 14 or 15.1. Create and use an interface. No, you don't have to do 15.2 on the enumerable. You know you don't have to add XML documentation to a class, and you don't have to create the class library. Again, we will go through the steps of doing this stuff. All right, we will go through the steps of doing this stuff when we go over the pretest on Thursday. Now, you're still welcome to do it and try it if you want to, turn it in if you want to. I won't grade it, but if you've got questions on anything, I'd be more than happy to at least try to answer them. All right, so with all that said, let's come in here and let's take a look at the program that we are going to do, which is this one right here, LB2 Photos. All right, you can see it's got a fairly complex interface. It has 1, 2, 3, 4 sets, 4 group boxes that hold radio buttons. All right, I cut mine down. What I did was this was really long here. So I've got all the stuff that you see, that you see in here. In other words, the width, the height, and these 3 are all together here. And then this stuff is down below. Now, there's probably better ways of doing a lot of the stuff that I did. All right, but I did it the way that I did it. All right, sometimes I'm sure that I probably ended up with more code than I would have otherwise. All right, what I really should have done, and I thought about this later, is I put these in as 3 radio buttons. I put these in as 5, these in as 5, and these in as 5. Would you say, well, yeah, that makes sense? Yeah. But they're all disjoint radio buttons. In other words, these 3 do belong to frame, these 5 to color, these 5 to material, these 5 to style. But what I could have done would have been to create an array of 3 buttons here, an array of 5 buttons here, an array of 5 buttons here, an array of 5 buttons there. It would have made it much easier as opposed to the code that I wrote. All right. But I'm just saying it's like live and learn. So I'll go back and try to fix that later. All right. So the idea, you come in here and you put an 8 and you put a 10 in here. Okay. In other words, you want something that's 8 by 10. You want it to be framed. You want it to have a black frame. All right. Around it in silver. And you want it to have a modern style. So when you look down here, all right, 8 by 10, so it got that from here. Framed photo, it got that from here. Silver and modern, it got that from here. I don't know why they didn't put in black, but they didn't, and it's okay. All right, and then figure out the entire cost. Well, that's based on the size. So one thing that's in here, and I don't remember where it goes, all 8 by 10s are $3.99, so that's what we start with. Okay, matted photos. No, frame photos. Yes, that's an extra 25 bucks. So that brings us to $28.99. That's where we got that number from. All right. So what we're about to do right now, and I want to make this smaller so you can see as much of it as possible. I know it's real small like this, but right here, we're going to have a 2-string that's basically going to be virtual. What that means is we want to be able to write different things down here based on what we selected up here. So we want to be able to take that 2-string method, all right, and it automatically is virtual, so we can change it around. Now, after we get started, the first thing we're going to create, literally in a minute, is this photo class. I'll make this bigger so you can see each one. So each photo will have a width and a height, all right, and it will have the width and it'll have the height that'll be passed in, as you can see, to the constructor. We will override the 2-string method, and we'll have a getter and a setter for the width and for the height, and we'll have a getter for the price. All right, hopefully that at least makes sense going over that. Then next, these 2 classes, let me make it a little smaller. Oops. These 2 classes that you see right here, matted photo and framed photo. Those 2 are children of photo. This is typically what's referred to as a UML or Unified Modeling Language class diagram. So these arrows, they all have meaning. All right. You'll notice it says photo is a child of object. Matted photo and framed photo are both children of photo. So when you look at this, what's different? Well, notice that any photo, whether it's just a photo or a matted photo or a framed photo, has a width and it has a height. So the width and the height that are in matted photo and the width and the height that are in framed photo, we're going to have to use that base thing that we talked about yesterday, so we can tell photo to handle those two. But a matted photo also has a color. A framed photo also has a material and a style. Both of them, again, override the two-string method. And for a matted photo, it has a color with a getter and a setter, and it overrides the price. And for a frame photo, it has a getter and a setter for the material and the style, and it overrides the price. So a matted photo is going to be this. So if we choose matted, none of these, we shouldn't be able to touch any of those or those, just these. If we choose framed, all right, then these should be basically blacked out or unusable, and these should be usable, and these should be usable. And we've got our costs right here. Now, what I did, I didn't think this was cheating, but I said, you know what? It says here 8x10s are $4, 10x12s are $6, and all other sizes are $10. Pretty obvious. I just read that to you, but you can see it. I said I put in here minimums and maximums. All right. So really, probably I should put the minimums in here. I made them. I think I'm going to change them from what I have, but I'm going to make this 8 is going to be the minimum and 10 is going to be the minimum here. For the maximum, I made it real big. I said I wouldn't imagine anybody'd have anything bigger than 10 feet by 10 feet, which would be kind of ridiculous anyway, but you get the idea. So I made my minimums and maximums for my width and height. I made them 120 because 120 inches is 10 feet. All right. So we'll have some stuff in here. We'll have some constants, as you can see, for these and for these. And again, we'll override the two-string. So this, again, is what our interface should look like. You'll notice that if I take this and I cut it down, I'm doing this on purpose here, I cut that down to here and to here. So that pretty much there, let me make it a little smaller. That's the interface right there. Well, when you look at mine, it looks a little bit different than that one. All right, it's the same interface. It just looks a little different because I just thought it was a little bit, I'm not even going to say unwieldy, but I thought I could write it a little bit better than they did. So my interface looks like this. It's virtually the same thing, but I made the width and height a lot smaller. I brought the frame type in here. I still have the color, the material, and the style. Still have the calculate button, added a clear button and an exit button. Where it says cost here, that's going to be in here. And where it's got the 8x10, etc., that's going to be in here. All right. So hopefully by just explaining all that to you, hopefully at least, it made some sense. All right. So let's start writing some code here. And it's 9:34. I'll go till around 10 o'clock or so. We'll take another break. All right. So the first thing I'm going to do is I'm going to come in and I'm going to create my photo class. Remember, we've got photo, and then we're going to have children of photo, which will be framed photo and matted photo. All right. So the first thing I'm going to do is I'm going to come in here. I'm going to right mouse click on the name of my project, and I'm going to choose add, and I'm going to go down to class right here. And this will be my photo.cs class. All right, so there we've got it, internal class photo. I'm changing this to public. All right, and now we're going to write this based on what I just showed you, in those requirements. All right, so I'm going to have two instance variables. they will be a private double. Well, I can make them double or decimal. It doesn't really matter. Let's make them decimal. And it'll be underscore width. And another one that's going to be height. Now that should make sense to everybody. Okay. And then we'll have our constructor. And it'll be public photo. Whoops. Photo. And we will have our decimal for width and our decimal for height. All right, width equal width, height equal height. All right, now, Grant, again, you're the only one listening right now live, but I'm taking for granted as we're going through this that if there are questions that you're going to ask. I mean, this is stuff we've done many times now. All right, so the next thing I want to do is I want to set my getters and my setters. And I'm going to use the more newfangled way of doing it. So I'm going to put in here getters and setters. Move this down or up. And I'm going to have public decimal width underscore width, and the same thing for height. And that's handling my getters and setters for height. All right. Then I want to override the toString method. All right. If you don't override the toString method and you're printing out a class, it's just going to basically give you some garbage. So what I want to say here is width times height. That's it. All right. So in other words, if I choose the 8x10, I want it to say 8, and I'll put an X in there and then 10 for 8x10. So I'm going to override the toString method right now. And it's public override string toString. Now it automatically gives you this return base thing, which I don't want. So I'm going to get rid of that. I don't want any of that. Okay. I'm going to put my own stuff in here, and I'm going to return the value of the width plus an X plus the height. So again, if I come in here and right here, I put in 8 here and I put in a 10 here, then this part that I just showed you is going to say 8x10. All right. So, I mean, about 30, a little over 30 lines. And actually, it doesn't even need to be that many. I can get rid of all this stuff. Closer to 25 lines, I would guess. All right, 30 lines. So we've got our instance variables for our width and our height, our constructor, which is going to handle initializing those instance variables. All right, and it's going to be grabbing these values. It's going to grab these values based off of what we put in the text boxes. But with what we put in the text boxes, we're going to run the validator on there to make sure they're not empty, to make sure they're integers, and to make sure they fall within our respective ranges. All right. And then we've got our getters and our setters. And we've got our overridden toString. So that is photo. All right. So let me do a file save all here. I'm not going to run it. All right. But that one, hopefully at least, is done now. Okay. So we've got that. So that basically is the equivalent, you could say, of an unframed. So the next one we'll do is matted. Then we'll do framed. So again, I'm going to right mouse click in here and choose add, go down to class. And I think we are told to call this matted photo. Put it in there like it's one word, capital M, capital P, and nothing else. All right. So we've got that. Again, I want to change this to public. But this time, I want to put in here colon photo. because is going to end up, this is going to end up being a photo. Now, don't worry about those errors. The biggest reason we got that error is for some reason I lost that curly. All right. So let me get rid of that. Okay. And that one's gone, and this one will be gone in just a minute. Now, one thing I didn't mention, so I'm going to mention it to you right now. I'm going to go back to this picture. All right. And go back to this. You'll notice that for matted photo and for frame photo, if you look at these boxes down here, these are called enumerations. When you create an enumeration, which is what we're going to do, we're going to make one called color, we're going to make one called material, we're going to make one called style. All right. We are creating new variable types. So whenever we use color.black, it's going to have a value of 0. Color.red will have a value of 1, etc. So you might look at that and go, okay, I get it, but why did you go 0, 1, 2, 4, 7? All right. What we could do at a later time if we wanted to is maybe, between green and blue, maybe we wanted to offer yellow in here. All right. So that could now become number 3. Maybe between blue and white, we wanted to offer other colors, maybe purple or fuchsia or whatever. So there is nothing that says that when you number these, they do have to be consecutive, but not consecutive right after one another. All right. So if black is 0, red by default would be number 1, green would be number 2, blue would be number 3, and white would be number 4. That's kind of how we did these two. But just to show that you can do it this way. So an enumeration is when you come in there and you're creating your own variable type. If I try to use the color and I try to use anything other than black, red, green, blue, or white, I'm going to get an error. All right. It would be like trying to use an integer, have something that's declared as type int, and putting a non-integer value in there. All right. Okay, so I just wanted to mention that to you. So there'll be an enumeration first that we're going to set up right now for color. Then when we do the frame photo in just a little bit, we're going to have an enumeration for material and an enumeration for style. And again, an enumeration is just a user-defined data type. All right, so the first thing we're going to do is we're going to put that enumerator in here. So color enumerator. And so I don't screw it up, I don't think that I can copy that stuff directly from here because that's like in a PDF. So I'll just do it like this. So black equals 0, red equals 1, green equals 2, and that should have had a comma. That's why it got screwed up there. All right. And there's an error in this right now, so I'm going to fix it in just a moment. So give me a second, and I promise you I will, because I set it up wrong. But we're going to just put these last two in here. Blue equal 4, and finally white equals 7. Now the reason that we're getting errors here is I foolishly, when I created this, forgot to say public, oh boy, public enum color, and then a curly brace. And all of these should have been inside of the curly braces. You'll notice that once I put those curlies in there, there's no more errors. All right, so that is my color enumeration. Okay, I still have an error up here because there's some stuff that I need. Basically, right now it's looking for a constructor. All right, and we're going to put that in a minute. But if you remember from what's in matted photo, I have now added this enumeration. All right, well, what's the next thing I want to add? Well, there is a new instance variable in here that is called color. All right, so we will do that next. So I will come down here and I will add my instance variable. All right, and it's of type color. So notice color. It recognizes that now as being a data type. All right, and I just called mine the color. Doesn't matter what you call it. All right, so now I've now got that. Now let's put in the constructor. So when I put in public matted photo, it'll have a decimal. Let's just collapse these down. I'll put in W for width. A decimal for the height, and a color, which we'll just call C. All right, now we've got those. We're not done though. All right, and then what I'm saying is we have to let the system know. I'm just putting this on another line so you can read it. And we'll do it just, I'm going to use the IntelliSense. What that is saying to us is, what is the parent, remember the parent is photo, the parent will handle the width and the height. We are only responsible for handling the color. So we'll say in here, underscore the color equals C. Okay. All right. The next thing we want to do, we only have one getter setter. That's for this one. The other one's handled up above. Again, public color, the color underscore the color. All right. So that's that. Okay. And right now I don't have any errors, but the only thing I want to do, just like we did a couple minutes ago with photo, is I want to come in here and I want to override the toString method. All right. So again, public override string toString. I wish it didn't do that, but it does this. Puts that return, it's all this in there. So I'm going to change that. It's going to be return base dot toString. What does that mean? That's going to handle, that's going to call this. So if it was 8 by 10, that'll handle the 8 by 10 part. All right. But what we also want to put in here is, in addition to that, we want to add the fact that it was we want to add the fact that it was matted. Come on, Jeff. All right. And we want the color. Again, just so you can see it all, the color dot toString. So in other words, if I choose matted, so if I come in here and I put 810 and I choose matted and I choose green, it should come in here then and say 8 by 10 matted green. All right, that's exactly what we told it to do right there. All right, hopefully that makes at least some sense. All right, so file, save all. And again, very quickly, so with our matted that we just did here, we again can get rid of that stuff. So we put it in enumeration. These are our possible colors. All right. And these will correspond, black, red, green, blue, and white. They correspond to those radio buttons right there. All right. And then we've got our brand new instance variable, which I call the color. And there's our constructor. We are telling the parent, which is photo, to handle the width and to handle the height, and we will handle the color. There's our getter and setter for the color. And again, we are overriding the toString method. So again, I'm just going to go on unless there's any questions. All right, then let's make our next class. So again, I'm going to right mouse click on here. I'm going to choose add and go down to class again. All right. And this next class that's in here, all right, the last class, whatever you want to call it, that is a framed photo. So FRAMED photo, and that'll be this one. Again, I won't need all this stuff. And again, that should be public. And again, this will inherit from photo. And again, I get these errors right now, all right, because it's expecting stuff to be in there that's not in there yet, like the constructor. All right. Now this one has two enumerators, and it's got, because we've got two more sets in here. In other words, we need an enumeration for this that I called material, and one for this that I called style. These are both 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. All right, as we set those up. So we will first, the order in which we do these is irrelevant, but I put the material enumerator first. All right, so public enum material, and that is pine is 0, oak is 1, steel is 2, silver is 3, and gold is 4. Again, because I'm a little squirrely about this. Oops. I should always have commas at the end. I don't know why I keep putting semicolons in there, but that's why I'm getting those errors. Okay, so that's our first enumerator. Then we will create another enumerator for our styles. So be consistent here. Try that again. Style enumerator. Just to try to make this go a little faster, I'm going to copy this down and just put it in here and then make my changes. So this will be style. All right, and again, there are 5 of them. There is simple, which is 0. There is modern, which is 1. There is antique, which is 2. There is vintage, which is 3. And there is eclectic, which is 4. All right, so those are all of our different styles. Let's leave it like that. Okay, so we're still getting that error because, again, we don't have the constructor. But before we put in the constructor, we need 2 different instance variables. All right, now I may or may not have mentioned this, but before, where is it? Because I may have left it off, so let's check. For our matted photos here, notice we said color the color. So in other words, when we did this, we made our instance variable of this type. We're going to do the same thing and make 2 more instance variables right here. So these again will be our instance variables. And we'll have material. And again, underscore the material. I could have just called it underscore material, I guess. And style underscore the style. All right, so those are our instance variables. Next, we need to put in our constructor. Don't know how I'm getting this stuff. Just like before, we'll start it with public and then the name, frame photo. And again, decimal for the width, decimal for the height. And now we're going to have two more things that we want in here. All right, if I put my mouse here, it is showing us, okay, that it is expecting something else. Okay, so it needs a width, it needs a height. All right, it also needs the material, and it needs the style. All right, but again, just like we did earlier, the base is going to handle the width and it's going to handle the height. Now, as soon as I put that in, notice all those errors are gone and all the errors are gone, period. All right. So in here, yes, we want to set the material, but we also want to set the style. All right. And again, we don't have to worry about the width and the height because those are being handled already by the parent, which is photo. Then we need our getters and setters. Again, do it the same way, public, material, material, the material, and public style, the style. All right. So one last thing to do here, and that is I want to come in and I want to set up or override my toString method, and then we're ready to start doing the other code. Okay. So again, override the toString method. Okay. So public override string to string. Okay, and again, we're going to start this off exactly the way we did before. And what I mean is, bit of that garbage. Okay. Probably is a way to turn off all this. Sometimes the IntelliSense is a pain in the butt. So return base dot toString. And again, that'll be the like 8x10 or whatever. Plus, now we want to say that it's framed. All right, plus we want the material. I don't want that. Rid of it. And we want the style, but we'll put a blank space in between them. There we go. All right. So again, this is going to be handling like 8x10. All right. This will be handling like, for example, vintage. And this will be handling, in fact, I think this one is, what is it for material? Like if I chose oak. All right. And then if I came in and chose antique. All right. So file, save all. So again, this is the framed photo class. All right. So we've got our enumeration for the material, our enumeration for the style. We've set two do instance variables. We've got our constructor where again, we are telling base, which means parent, you handle these two things. We'll handle these two. We handle them in here. We've got our getters and setters, and we overrode our toString method. All right. So now we should be done with our three classes. Okay. I may have to open them up again, but to try to keep things a little simpler, I'm going to close this. I'm going to close this. I'm going to close this. And this. So right now I have come in myself and I built the interface, as you can see. All right. I've also set the tab order, and I've set the accept button to here, the cancel button to here. All right. So I can run it now. It won't work. All right. Put it this way. I guess I should say it'll partially work. So I can put something in here and something in here. Clear works. All right. Plus, the other thing I want clear to do, just so you see this, is I want it to go and clear out all these, whatever is chosen here. I want all these buttons to be unchecked. And I want these two things to be emptied. And I want the cursor then to go here. Let's put the cursor here. So clear. All right. They're all unchecked. And there's my cursor and everything's empty here. And exit also works. Okay. So let's start writing our code, and we're just going to put in some of the global stuff that we're going to do, and then we'll take a break. All right. So I did come in here and I added this. This is all taken directly. All right. This is all taken in here directly from our requirements. Okay. Now, again, I set in some minimum width and height. I'm going to change that to 8 by 10 because it looked like that would be the smallest one that they would put in here. That's fine. And I don't know. I mean, making it 10 feet by 10 feet to me is kind of stupid. So let's say that the biggest one we plan on having would be 6 feet by 6 feet. So we'll make that 72, which is 72 inches is 6 feet. And we'll make that 72. Now we could always go back if we wanted to or needed to, we could go back and change that. Right? Nothing that precludes us from doing that, but I think that's fine the way it is. So those are my global constants, and they were arbitrary on my part. All right. Well, that's not all of them. I'm going to add some more right now. So I have a const decimal, and I just called it what it was. So 8x, better spell it right, 8x 10, that's an 8 by 10, and that's equal to 3.99 m const 10x 12 const decimal 10x 12, and that is equal to 5.99 m. Another one, which was for all other sizes, so const decimal, I just called it other sizes. And I set that equal to 9.99 m. Again, this is all taken from the requirements. Const decimal matted. We are told that if you add a matting, it's $10. Just putting 10M would have been fine there, just so you know. And a const decimal framed. And that is equal to 25.00 M. All right. Okay. That is it for my constants, but I had quite a few global variables in here. All right, probably about 10. So we want to put these in, explain what they are, and then we will take a break. All right. I've got a decimal, which is going to be width. Just set it equal to 0.00 m. Another decimal for the height. Again, that's equal to 0.00 m. All right, a decimal for the total cost, and that's going to be everything calculated together, and that's equal to 0.00 m. All right, so that's the first three. Now the next three, I'm going to put these in here, and it'll take the next four, it'll probably take a little bit of explaining. All right. I want a variable that I'm going to be able to use that's going to hold this value, another one that's going to hold this value, another one that's going to hold this value, and another one that's going to hold this value. So in other words, if I run this program and I come in here and let's just say we put in 10, 12, and I choose this and this, I can't really choose all of them, but you get the idea. So let's just say I could. All right. I want variables to hold that that's blue, that that's steel, that that's eclectic, and that that's framed. All right. And there are four of them. So I'm going to put those in there next, right here. So they're of type radio button. Notice I can do that, radio button. And I'll call them what they are, radio button frame, because that's the name of the first one. And then radio button color. Then another one, radio button. We call that one, I spelled that wrong, that's why it's looking weird. All right, and that will be radio button material. And finally, the last one will be radio button, and that'll be radio button style. Now you'll notice that right now, at least, it says what? It says radio button is an ambiguous reference between these. It says show potential fixes. So I'm going to click that, and it says, oh, you probably want to put in this using statement. I just always grab the top one that they recommend. So I'm going to click on that, and it added using radio button right there. Now it may have been the second one that was supposed to go in. So let's see what this says. It says cannot declare a variable of static type. Well, I'm going to tell you what I'm going to do. I'm going to remove this. Because I don't remember which one I put in here. So let me remove this. And my error should be back here now. So under potential fixes, let's try this one. All right, and you notice in that case, now they're both undone. And it changed that to using radio button equals this. All this is saying is when I use radio button, the word radio button is replacing having to type in system.windows.forms.radio button. All right, so that's what we're doing here. All right. So I now got this. The only thing that's green here is we're not using these right now. So it's just warning us that we're not. All right. And it's just about 10 after. Let's just take 10. We'll come back again at 20 after 10, and we'll pick it up right here. I'm not saying we can get everything done by 11, but that's what I'm going to shoot for. Okay. So I'll see you back here at 10:20. Got to refill my water. Give me just a second here. Okay. All right. What I'm going to do right now is I'm going to bring up the original version of this. Okay. And this is something I wrote, but I wrote it a while ago. You can see it wasn't, I prettied it up since then, etc. But there's well over 300 lines in here. And I tried to bring some of the other code in and it just didn't like it. So let me go into here. It's got the same stuff in here as far as the comments, etc. Same thing, 8 by 10 with all this other stuff, everything I showed you before. There's nothing new in there. There's a few other things in here. This is going to be the string that we end up putting in here, the stuff that's going to appear on here a little bit later. So don't worry about that. All right. But what I want to show you is this right here, because this is where it gets confusing. This is why I decided not to make it, not to assign this problem. Because when you look in here, we've got 3, 8, 13, 18 different lines. What these are doing is basically these are doing the wiring in here. And what I mean is, what this is doing is it's saying, hey, these, when you click on one of the things that's in here, either unframed, matted, or framed, when you click on it, it's a check changed event that comes up. And when that check changed event comes up, we are basically wiring it up. So it says, hey, this one is the framed, this one is the matted, I'm sorry, this one is unframed, this one is matted, this one is framed. Then the same kind of thing with the color. All right, because by default, this would be as if I went in here and double clicked on each one of these buttons individually and put in the code. Doing it like this, I can basically set the handlers up in this way. Now, I'm not saying does that make sense or does it not make sense? But again, what I'm doing in here is physically wiring up and letting the system know when you press one of those buttons, the event handler that's supposed to run that's associated with it. Like I said, I don't know if that makes a lot of sense or it doesn't. Okay. So, like I said, there's a bunch of code in here, but I'm going to go over all of it right now. So, this first one under framed check changed. Okay. So, what is that? Framed check change. Well, notice what it's saying in there. This is the first time we've ever used this. This is sender. That's who did this. So if it was a radio button, okay, we then basically we want to let it know that the radio button is the sender. But that sender is of type object, so we have to go and cast it into a radio button. I'm not saying does that make sense. We're going to go through another example that's going to be similar to what we're doing right here in this code, right in this method when we get into databases, and I think it'll make more sense then. All right. And then what we're saying is basically we want you to go in this frame string, we want it to say 8 by 10 or whatever it is. So in other words, this right here is going to be either unframed or muted or matted, I should say, or framed. All right, that's what that is going to be. So that's what this is. All right, and if it's framed, now think about this, okay? If it's framed, try that again. If it's unframed, what we want to tell it to do is we don't want you to be able to do anything with any of these or any of these or any of these. In other words, if it's unframed, color makes no sense, material makes no sense, style makes no sense. So turn off all of them. Now, we could have gone through all the trouble. We could have gone through all the trouble of turning off each one of those 15 buttons. But if we disable the group box, you can't do anything with the buttons inside of them. So what we're saying again is if we chose unframed in here, right there. So if we chose unframed right there, disable these five, and these 5 radio buttons. And we are disabling them by basically by disabling the group boxes that hold them. All right. Next is then what happens if we choose matted? If we choose matted, the idea is all of these should now be available. All right. But these and these should be unavailable. So when you look here, if we chose matted, all right, we just by default, we just say black because it's the first one. You could have chosen any one of these, but I just made that one true. All right. By making this the group box true, now all of them are enabled, but I just chose one, so one is chosen all the time. But I want to take the other 2 group boxes and disable them. Finally, if it's framed that we chose, then there's no color, so we'll make that false, but there is a material, and there is a style. So we'll set both those group boxes to true, which will enable all those. And then pine and simple are the first ones. You don't have to choose the first one as your default like I'm doing, but to me, it just made sense to do that. And default, well, if that's the case, everything, it should never hit that. But if it does for some reason, I'm just going to handle it the same way I handle this. I'm going to make sure that all those group boxes are disabled. All right. Now, just so you see this in action, so to speak, I'm not going to run the whole thing, but I want you to see this right now, and that is this, that when I run it, all right, and it doesn't matter, I'll put in here 8 and I'll put in here 10, okay? That's fine. But as soon as I choose unframe, none of these should be checked. None of these should all become disabled. You can see that it does. That's exactly what we'd want to have happen. Now, if we choose matted, which I'll do next, these should become enabled. The black should be chosen. This should stay disabled, and so should this. And that's what happens. Finally, if we choose framed, which I'll do in a moment, this should be disabled. This should be enabled with pine chosen. This should be enabled with simple chosen. And you'll see that that works. The only thing I thought later that I really should have done that I didn't do was then to disable this one. But it doesn't hurt anything. Now I'm asking the question again. Sorry, I'm leaning on you here, Grant, but does what's happening in here make sense?
Yeah, I think so. It's you're right, that's just a lot of code, but I think
Yeah,
it's pretty straightforward. It's just a
yeah.
lot of it.
Well, and the reason that I decided to actually show you all this code for this one is this is more an actual application that you'd create. All right. I mean, it's got several classes. It's got controls that we don't typically use. All right. And I've done this thing twice. The one that I'm going to show you here, I didn't bring in the validator class. I don't think I've got it in this one. Let me look. No, I use try catch, but we could have brought in the validator. That's the reason I tried to redo it here, but for some reason it just was wonky the way that it was working. That's why I went back to the old one. All right. So now we've got this handled, and based on this, we've got these handled. But, well, what do we need to do? We need to make sure there's something in each one of those text boxes above. We want to make sure it's numeric, and probably we'd want to make sure it's within range. So when we click the calculate, what are we doing here? Well, there's that keep going thing again. We're going to validate the width. If the width is valid, we're going to validate the height. If both the width and the height are valid, then we will calculate the cost. All right. So how are we going to validate these? Again, did this a couple different ways. It probably would have been cleaner to bring in that validator class. And that's what I had the class do, to be honest with you. All right. So we did part of this as a class, no pun intended. But then I had them go in and change this stuff themselves. All right. So the other thing too is notice it says width inputted was not numeric. I really should have added to there something like plus, oops, not that. Here, like plus, I'm going to put a backslash n here, two of them. Backslash n, and then plus. And this was called FE, so FE dot message. All right, just because I'm getting these things in here. So again, I should have come in here and put in a backslash n, and then a plus. And in here, I'll do the same kind of thing. So I'll say OORE dot message. All right, and I think there was one. Is there one more? Yeah, down here. Two more here too. All right, because I did it for both the height and the weight, so, or the length and the width. So let's bring in this. here, and we'll bring in the one here, but that'll be OORE. Okay. So again, taking it from the top, go back here to the calculate button. We're going to validate the width. All right. And in a try-catch block, try to do a convert, and that should have been to well, I guess I kept them as double in here. I think that's the way Mr. Smith had them. But I thought later decimal made more sense. So, all right. So we're trying to do the conversion. If it fails, we're going to catch it. It'll throw a format exception. All right. We'll set the width. We'll set the text box back equal to nothing because we put something in there that was illegal, and we'll set the focus and we'll return false. All right. So that's a format exception. There's also an argument out of range exception. So if you put in a value that's less than 0, it should throw that. Now, it's not going to because it's just going to do a convert to double. So really, we should have put in here, if that width is less than 0, throw a new argument out of range exception. Okay, so in other words, there's the conversion. They should have said, if width less than or equal to 0, throw new argument out of range exception, like that, because that'll handle it here. Okay, and I'm going to grab that one, put it into the other one too. Oh, it is in that one. Okay. All right. So put it in one, forgot it in the other one. So does what's going on here for the validation, does this make sense?
Yes.
Okay. So that's both those. So in other words, when you get up to here, all right, you're ready to calculate the cost. Otherwise, you'll return because there was some kind of an error. So let's calculate the cost. All right. First, figured out the area. So if it's 8 by 10, it'll be 80. All right. If it's 10 by 12, it'll be 120. Otherwise, it's something else. Okay. So it doesn't matter. It'll figure it out regardless. Okay. And it'll set that total cost in here, which is the area plus the frame cost. Okay. And here's where we're calculating the area. Again, if it's 8 by 10, right there, if that's 8 and a 10, it'll be that 8x10. If it's 10 and 12, it'll be 10x12. Anything else we're told is other sizes that is set to $9.99. So in other words, when we get back to here, this will be either $5.99 or it'll be $8.99 or it'll be $9.99. All right. And then for our frame cost, we're calculating that in here. This is where the object-oriented stuff comes in, okay? Because if you'll notice here, FC is just frame cost. Then we're doing a switch on which radio button from up above we chose. In other words, was that unframed? Or was that matted? Or was that framed? If it was unframed, the frame cost is unframed, which we set up above, which is nothing basically. We set a new photo, we pass the width and the height. We don't have to worry about style or material or color because there isn't any, it's unframed. All right. But if it's matted, and this took some work, I mean, this took some Googling to tell you the truth. All right. Then what we wanted to do is we set it to matted, but we wanted to make sure we grab the color enumeration that's in there, because that's what has to print in that message that comes at the end. And when we set up a new matted photo, it requires a width and a height and a color, one of those color enumerations. Then finally for the framed, all right, again, it's going to require a material and a style. So when we instantiate a new one there, we've got the material and we've got the style. I actually thought of giving you this one for the regular test for this, but I thought, geez, you're going to be going nuts and you're going to be looking up stuff. And this particular example is almost a recipe for disaster. All right. Then there's just the clear stuff. So let's take a look at it. So if we come in here and we put in here 8 and we put in here 10, that should be 80. So that should be, I think that was $5.99. So if it's unframed, I guess it's $3.99. And it just says 8 by 10. All right. If we change that to matted and we calculate, it's now $13.99 because the mat is 10 bucks, I think it was. And now it says 8 by 10 matted and black in here. This is grabbing the color from the enumeration. So we could have like done a 2 lower or does, but it's okay the way it is. And finally, if it's framed, then we pick out something from here. So again, steel and eclectic, calculate, it's $28.99 and it's steel and it's eclectic. When I clear, if I come in here and leave that blank, with inputted was not numeric. And then here's the thing we just added, input string was not in a correct format. And it puts you back here. If I put in a value that's negative, non-positive with inputted was less than or equal to 0, and it was out of range. And the same thing will happen. I don't think we have to really run those, but the same thing will happen also for the height. So if I come in here and do a 10 by 12, these are all going to change. It was $3.99 and notice it's now $5.99. So it's $2 more. If I make this white, it's now $15.99. Finally, if I make this framed, I get all that. Okay. So that was a lot. And I guess I really did micro encapsulate it for lack of better words. Is there anything that's in here that you have an interest in me talking about?
Could you go over actually just that switch statement
This
again?
right here?
Yeah.
Sure. All right. This right here is going to be it's going to be whatever one of these that we chose up here. So that's going to be either unframed, matted, or framed. So that's going to be 0, 10, or 25. Okay. That probably made sense at least. And let's go back into it then. All right. So now that we know what that cost is, we know when we create a new object, this is going to be a regular photo because it's unframed. There's no matting. This is going to be a matted photo, so we know it's going to have to include a color. This one is going to be a frame photo, so it's going to have to add a material and a style. All right. So if it's a regular photo, all it needs, this is calling the constructor. And its width and height have both been set. Those are the values. That is txt width dot text and txt height dot text. But we did a conversion on them previously. We were able to convert them to type double. All right. And then this for the results, that's grabbing everything in our photograph and it's calling the toString method. So it's calling the toString, but it's calling the toString from photo. So it's calling that toString right there. So when it says 8x10, that's all that it's got. All right. Then on the other hand, if it's matted, and like I said, this is where it's a little hinky, for lack of better words. Let me move this way over. All right. In fact, I'll put this over 2 lines just so you can see everything here. All right. This right here For color enum, this is telling it to go through our enumerations, all right? And it's telling it to parse, and it's telling it to base it off of what radio button we chose. And since it needs right there, since it's going in, all right, and it needs to basically match. So it's trying to match. I guess I could have gone in and just made all these uppercase, but that's not what it showed. I believe our requirements that try to follow them. See, they're not in uppercase. All right. So that's where the two upper comes in on there that you saw right here, because we're doing a comparison. All right. So it's saying grab whatever radio button we chose and map it up with the enumerated value. Okay. Then once I've got that, now create a new matted photo. Again, width and height will both be handled by photo, but color enum now, which is what we just set here. All right. In fact, let's do this. I don't know if this will help. I don't know if this will help at all, but I'm going to just put this in here so you see it. I'm going to put in a message box dot show right here, and I'm going to say the value of color enum is all right. And we can do it for the other ones too, but I think if we just do it for one here, that should hopefully make sense. All right, in fact, let's do that. All right, so we'll do both the value of material enum here and the value of style enum. All right, so let's just grab one of these. Doesn't matter what we choose for size. Let's make it 8 by 10, and we will make it matted. So it's black there. In fact, let's choose a different one. Let's choose blue. Calculate. Oh, okay, that was on me. That should be an 8, and that should be a 10. So the value of the color enum is blue. Okay. And if we do it again and go to here, and we choose pine and eclectic, all right, the value of the material is pine, the value of the style is eclectic. All right, so that's what we end up passing into there. All right, and then again we create the object of that type, and then this right here, that is printing out whatever you're going to see in here, and it's making sure that it calls either the one for matted photo MP, or for frame photo FP, or for a regular photo, which is just P. Did that help?
Yes, thank you.
Okay. Anything else?
Not at the moment, no.
Okay. So one last time, make sure that you do numbers 1, 5, and 6 for the labs. All right, now I'll put this in the email that I'll send out later. For the written tests, make sure you do 14 and 16. And for the homework, do the 14. And I'm going to check on that to see if I have to send you the starter files for that. All right. Tomorrow will be a lab, and tomorrow I will send you in tomorrow's email. It will have the retest on it. Now, unless I change it, the pretest is going to be a lot different. And what I mean is, it is very, what I wanted to write for a pretest would have involved us having 4 or 5 different forms and going back and forth, and it would have been a lot of code. So I wrote it as a console app. All right. It'll still allow us to see everything. Plus, I'm going to show you something that we haven't even talked about before. All right. So with all that said, sounds like you have no more questions. I will talk to you then on Thursday morning at 9:30. See you then.